Hey everyone, and welcome. Today we're bringing you a highly focused explainer based on an absolutely fascinating classroom demonstration by Anubhav Sir. We're going to look at a scenario that honestly sounds like it belongs straight in a superhero movie, but is actually a total masterclass in shifting your perspective. We're talking about falling objects, incredibly heavy tools, and a solution that completely defies our everyday logic. Let's dive right in.
Okay, seriously, think about this for a second. You have a pipe, right? And it's falling. Now, your instinct is probably going to be to grab it, support it from underneath, or, I don't know, maybe tie it to something above. But what if the only tool you're given to save this falling pipe is a huge, cumbersome hammer? And not just any hammer, specifically a hammer so hefty they jokingly call it Thor's hammer. How exactly do you use a massive weight to stop something else from falling down? I mean, it sounds like a trick question, doesn't it? Adding weight to a falling object should just make it fall faster. But, as we'll see from Anubhav Sir's demonstration, the universe has a very, very clever loophole.
Section 1. The Hammer's Challenge.
So, picture the scene from the source material. Anubhav Sir stands before his class with a real-world physical puzzle. First up, we have our subject, the falling pipe. Next, he brings in the wild card, this remarkably heavy hammer. He looks out at the students and simply asks, "Who wants to try?" And a brave volunteer actually steps up to the front to take on the challenge. Right away, you can see the volunteer realize the intense physical reality of the tool in their hands. Anubhav Sir even stops to caution them, pointing out just how incredibly heavy this Thor's hammer really is. And then comes the crucial third step, attempting to actually balance the entire system so the pipe doesn't hit the ground.
Moving on to Section 2. Intuitive Attempt and Failure.
Naturally, the volunteer tries to solve the problem the intuitive way, by simply holding the hammer or trying to manually rest it to prop the whole thing up. And this prompts a brilliant, really witty observation from Anubhav Sir. He tells the student, and I love this, if we had to do it like this, why would we give a hammer? We could just hold it with our hands. It's a funny moment for sure, but it fundamentally hits the nail on the head regarding the parameters of the experiment. The hammer isn't there to just act as a rudimentary hand or a crude prop. Using it just to manually hold the pipe, well, it completely defeats the purpose of the whole physics challenge they're exploring.
The core lesson here is all about our physical intuition. You see, our brains are basically hardwired through everyday experience to believe that to stop something from falling, you gotta push up against it, or rest it securely on a solid foundation. So resting the hammer against the pipe seems like the most obvious, common-sense way to balance it. But Anubhav Sir points out that while, yeah, sure, you can balance it by resting it like that, it misses the true magic of the physics at play. There's a much more complex, deeply fascinating challenge hiding just beneath the surface of this entire setup.
Which brings us to Section 3, the hanging magic.
This is where the crucial pivot happens. Anubhav Sir takes us away from what feels comfortable. He establishes that balancing the pipe by just resting the hammer is the basic, uninteresting method. The real test of physics is this. Can it be balanced by hanging the heavy hammer from it? Just let that sink in for a second. You have a pipe that wants to fall down, and the proposed solution is to hang a tremendously heavy Thor's hammer completely off of it. I mean, every ounce of our logic screams that adding a heavy, hanging weight will instantly drag the pipe to the floor. It feels like a total paradox.
In the classroom, you can tell the tension peaks. Anubhav Sir says, "Come, let's try and see." He looks at the student and asks, "Ready?" It's the ultimate moment of truth. You can almost feel the suspense in the room as this ridiculously heavy hammer is positioned to hang directly from the vulnerable pipe. The expectation of a massive loud crash is practically hanging in the air.
But the crash never comes. The hammer is hung, and the pipe stays exactly where it is. It balances perfectly. No way, right? This immediately triggers the ultimate question, the one Anubhav Sir directly poses to his completely awestruck class. So what happened that even after hanging the hammer, it didn't fall? Seriously, how did adding a huge downward pulling force somehow create perfect stability?
And that brings us to Section 4, Secret of Rotational Equilibrium.
The answer, as Anubhav Sir reveals, all comes down to understanding rotational equilibrium. Basically, rotational equilibrium is the scientific principle dictating how forces can completely cancel out each other's tendency to cause rotation. In this specific demonstration, hanging that heavy hammer fundamentally shifts the entire system's center of mass. By placing that massive weight securely below the pivot point, it creates a counteracting force. So whenever the pipe tries to tip or wobble even a little bit, gravity pulling on that incredibly heavy hanging hammer actively pulls the entire system right back to the center.
Even though the hammer is remarkably heavy, its specific position creates a totally flawless balance.
And this just brilliantly illustrates how a simple shift in perspective can completely change our understanding of the world. What looks exactly like a magic trick, literally defying gravity by hanging a heavy weight from a falling object, is instantly transformed into scientific reality once you grasp rotational equilibrium. It tells us that stability isn't always about just propping something up from the bottom. Sometimes, actually, it's about arranging forces so they beautifully and perfectly oppose one another. It takes an impossible balancing act and turns it into purely logical physics.
Which leaves us with a pretty fascinating thought to take away from today's explainer. Once you know that something as simple and heavy as a hammer can be used to invisibly balance a falling system, you start to look at the structures all around you a little differently. Think about it. How many other magical balancing acts in the real world, from the massive cranes constructing our skyscrapers to the suspension bridges we drive over every day, or hey, even the way you intuitively carry a heavy bag, are really just the invisible forces of rotational equilibrium quietly at play? It's pretty amazing. Keep your eyes open because physics is quite literally everywhere. Thanks so much for joining me today, and keep questioning the impossible.